Hello, this is Lab 4. For my introduction, the purpose is to use current and energy conservation, um, predict and examine RC circuits with ohmic resistors and capacitors, and use multimeters to calculate values related to the circuit. So for my preview of results, current 1 and current 2 were found to be 0.0202A. Um, so some fundamental models and principles for this are the node rule, steady state circuits, conservation of energy, conservation of charge, Ohm's law, which is V equals IR, Kirchhoff's loop rule, resistors, capacitors, and circuits. So for some assumptions, resistance of the ammeter is negligible, resistance of the wire is negligible. For the RC circuit, it was developed 2 ammeters, two 1.5 volt batteries, and two resistors. Current 1 and current 2 predictions is 0.02041 amps, and the actual value that I found was 0.0202 amps. And if the connections to one of the ammeters is reversed, the value of the current would just be the negative of the actual value. For the RC circuit continued, an ammeter was replaced with a voltmeter, and the ammeter was found to be 0 volts, and the voltmeter was found to be 3.04 volts. The voltmeter has a high resistance, so the ammeter shows 0 volts. Um, for our last circuit, the RC circuit consisted of two light bulbs, one 9 volt battery, and one 200 MF capacitor. The capacitor is shown, or the capacitor is connected to the light bulb. The capacitor slowly discharges, gradually decreasing the current through the light bulb, and the light produced in the bulb grew dimmer. So some possible sources of error. Um, One could be the initial circuit setup, and the second one is previously used batteries, which led to inconsistent voltage. For our discussion, what what if you were doing this in a lab in real life and used the national ammeter instead of an ideal simulated ammeter? What's different about a real ammeter and how it affected the circuits you hooked it up to? If you so basically more current would be able to move in our circuits as the ammeter would have zero resistance, thus altering our predicted and measured current. What if you're doing this live in real life and used a real battery to charge a real capacitor with no resistor in the circuit? How would our ideal model predict the capacitor to reach full charge? Will this prediction happen in real life? So basically, the capacitor would instantly charge if there is zero, if there's no resistor. And that concludes my presentation.